Welcome. In this video we continue Unit 3 on functions, and in particular we look at objectives 5 and 6. 5 is find the domain of a function defined by an equation, and 6 form the sum, difference, product, and quotient of two functions. So how about the domain of a function? The domain of a function defined by an equation. So we'll look at the definition of this thing. We'll start with an example. If f of x equals 2x divided by x minus 5, then f is defined for any x value other than 5. So when I say that it's defined, I mean that I can put in an x value and get out an actual number, as long as the x value that I put in isn't 5. And so this brings us to the idea of the domain of a function. The domain of f is the largest set of real numbers for which the value f of x is a real number. So in this particular example, if f of x equals 2x divided by x minus 5, the domain of f is the set of all x such that x does not equal 5. So all x's in the world, every real number x except for that particular x value of 5. Another way of writing this is with interval notation. We can say all the numbers from negative infinity up to 5, but not including 5 because I have a parenthesis, unioned together with all the numbers strictly greater than 5. On the real number line, I suppose you might even draw it out something like this. I have a 5, then I use a parenthesis this way, I have a shade in everything to the left, I have a parenthesis that way, shade in everything to the right. So every number is represented except for the number 5. The domain of a function f is a new idea, but we have already seen this idea, the domain of the variable x in an expression. So these two ideas really go hand in hand. It's the same idea. So sometimes functions are expressed as fractions. Generally, a function like f of x equals x to the fourth minus 10 divided by x squared minus 9 is defined everywhere except where the denominator is 0. Whenever you have a fraction, if the denominator is 0, then that whole fraction becomes undefined. So what is the domain of this particular function? Well, I need to figure out where is that denominator 0. And then my answer is going to be everything except for where the denominator is 0. So I might do a little calculation. I say to myself, x squared minus 9 equals 0. So I'm trying to find the bad points. Alright, so x squared equals 9 by adding 9 to both sides. And so we find x equals 3 or negative 3. So those are the two values that make the denominator 0. So I might say that the domain of this function is actually the set of all x such that x does not equal 3 and x does not equal negative 3. Or I could write this in interval notation. Negative infinity up to negative 3, union negative 3 up to positive 3, union 3 up to positive infinity. So all real numbers except for negative 3 and positive 3. How about this one? Find the domain of g of x equals x over x times x plus 1. Well, again, it's wherever the denominator is 0. And the denominator is going to be 0 if either x equals 0 or x equals negative 1. So let's write the set of all x such that x does not equal 0 and x does not equal negative 1. There's that domain. And by the way, the numerator doesn't matter at all in any of these. The numerator can be anything. Alright, last example, h of x. h of x is the function 12 divided by x squared plus 4. Where does that denominator equal 0? X squared plus 4 equals 0. So x squared equals negative 4. Wait a second. X squared equals negative 4? That's not ever possible, right? So no value of x makes that denominator 0. So in fact, the domain is all real numbers. Every real number works. Here we go as a nice interval. Negative infinity up to positive infinity. So that was fractions. Let's look at square roots. This is another kind of a function where you'll have to be careful with the domain. Generally, a function like f of x equals the square root of x minus 8 is defined everywhere except where the radicand is negative, and the radicand is that stuff under the square root sign. So, in this particular problem, let's say that f of x equals the square root of x minus 8. What is the domain? It's where x minus 8 has to be greater than or equal to 0. So that is the domain. That's not the bad points, that's actually the good points. So if I add 8 to both sides, x is greater than or equal to 8. Oh, so that's actually my domain. It's the set of all x values where x is greater than or equal to 8. Sometimes students forget that 0 is okay under the square root sign. The square root of 0 is a perfectly good number. It just equals 0. So I can express this as 8 up to infinity. I use a bracket on the left because 8 is included, and then infinity, and then infinity always gets a parenthesis. How about this? G of x, the square root of x plus 5. Well, let's see here. X plus 5 must be greater than or equal to 0. So x is greater than or equal to, I'll subtract 5 from both sides, negative 5. So it looks like my domain in this case, negative 5 up to infinity. Find the domain of h of x equals the square root of negative 3x. Alright, negative 3x is greater than or equal to 0. So something funny is happening here. Since I have a negative, it looks like those x values themselves have to be negative. Well, something happens with an inequality. If I negate both sides, it switches the direction of that inequality. So let's start that. Let's say 3x is less than or equal to, well, what is 0 when it's negated? Negative 0, 0. And then I can divide both sides by 3, divide by 3. Now, 0 divided by 3 is okay. That's just 0. So I end up with x is less than or equal to 0. So, as an interval, negative, not 8, how about negative infinity up through 0, and I'll put a bracket on the right of 0. Fractions and square roots. All right, let's combine the two together. Find the domain of f of x equals 3 over the square root of x minus 8. So I need that this denominator can't be 0. And so previously when I was finding the domain with a square root, previously I said x minus 8 had to be greater than or equal to 0. But now, since it's in the denominator, I don't want the equals part. X minus 8 has to be strictly greater than 0. So in other words, x, I'll add 8 to both sides, is greater than 8. Strictly greater than 8. How about the domain of this function? Well, there's something in the numerator. Do I need to worry about that? I don't think so. The denominator is the only part where bad things could happen. Now, there's two factors here, x minus 10 and the square root of x minus 5. And these are being multiplied, so if x was actually 10, that would be a problem, because that would make this entire denominator 0. So right off the bat, I know x does not equal 10. But what about the square root part? Well, like before, it needs to be greater than or equal to 0. Oh, but it can't actually equal 0 because it's in the denominator. So I want x minus 5 strictly greater than 0. So in other words, x is strictly greater than 5. Now, these two things get combined. X is not 10, and x is greater than 5. So it's all things greater than 5 except for the number 10. How would we write that? Maybe something like 5 up to 10 union 10 up to infinity. How about this guy? So I've got two things going on. I have a square root on the top and I have a number down in the denominator. For that square root to be defined, I need to have the radicand greater than or equal to 0. And it's okay to be 0 since it's in the numerator. So 2z minus 18 greater than or equal to 0. 2z is greater than or equal to 18. And then divide by 2. Z is greater than or equal to 9. So that takes care of the numerator. What about that denominator? That denominator tells me z does not equal -1. Because if z was -1, that whole denominator would be 0. So two things have to be true. Z is greater than or equal to 9, and z does not equal -1. Oh, well, it's almost like that second part, z not equal to -1, doesn't even really matter, right? Because down below I know that z has to be greater than or equal to 9. So I get bracket 9, comma infinity as my solution. Alright, one more. Numerator, nothing strange going on there. Denominator, it looks like I just need to make that denominator not 0. So the bad parts, bad things happen when 3t minus 9 equals 0. So in other words, 3t equals 9, or t equals 3. So maybe this one wasn't as bad as we thought. The domain is all numbers except when t equals 3. Domain t does not equal 3. So how about, here we go, I'll use the set notation. T such that t does not equal 3. There we go. Let's talk about combining functions. How about the sum and difference of functions? If f of x equals 2x to the 4th plus 7 and g of x equals x plus 1, well, I can just add these two together, right? F of x plus g of x is the first part, there's my f, and the second part, there's the g. And combine them together, it looks like the numbers actually add. So be a little bit careful here. I have a 7 and a 1. Those add up to 8. Well, there's a new, better way of indicating this sum. And that is, put the f plus g in parentheses and call that of x. So that new function, this f plus g, that is a new function. That is the sum of the functions f and g. What is the difference, f minus g of x? Well, we just can figure out the difference of those two. So 2x to the 4 plus 7. Then I have to subtract off g of x, so I subtract off x plus 1. But do you see, I made a mistake. What is my mistake? The mistake is that I need parentheses around here, because I'm subtracting off the entirety of the g function. And when I simplify, the negative distributes, so I get 2x to the 4 plus 7 minus x minus 1. So I have a plus 7, I have a minus 1. That gives me 2x to the 4 minus x, and then how about plus 6? Plus 6. And what is the domain of f plus g? So I'm actually going back up a little bit to my f plus g. Well, it's got no fractions in there, so that's not a problem. There's no square roots, so that's not a problem. In fact, this is just a basic polynomial, just x's with multiplication and addition. And the domain of a polynomial is all real numbers. So no numbers that make it go bad. So all real numbers, everything from negative infinity up through positive infinity. So how about this? F of x equals x plus 8. G of x equals the square root of x. F dot g, that means product. So f times g of x is really just the product, x plus 8 times the square root of x. And I'll just leave it like that. What's the domain of that guy? Well, the x plus 8 part doesn't matter. X can be anything. But that square root part is what might give me a little bit of trouble. The square root's not defined for negatives. So for the square root part, x has to be greater than or equal to 0. And basically that's it for the whole function. So bracket 0, comma, up to infinity with a parenthesis. And how about the quotient of functions? So f is in the numerator, so I get x plus 8 in the numerator. G is in the denominator, square root of x in the denominator. And there's my quotient of functions. And now it's going to ask, what is the domain of f over g? What is the domain of that quotient? Again, it's just wherever that denominator is not 0. So, but also it's a square root, so it has to be actually, x is greater than 0, strictly greater than 0. And so that'll become 0 with a parenthesis up to infinity. There we go. So we've looked at some interesting ways of combining functions, and we've thought about this, the domain of a function. And that is our conclusion for section 3.1.